While explaining the R output, I forgot to explain you that how will you visualize the relationship of variables rather easily using R. So let me explain that part pretty quickly, and then I'll explain you how to do factor analysis using SAS. So what you do here, the fact, if you look at, fact has many components, like you can see the loadings here is available. You can take this loading, just column 1 and column 2 into the load. So let's take a look. So this, if you look at 0.855, 779, all those things has gone into a matrix, load matrix. This load matrix has 6 rows and 2 columns. Now let's plot that. So first time when I'm going to put this, you don't see anything, but you will see when I'll put the name of the variables, for which I'm using names command. I'm taking names from this particular data set. So let's put the name and then let's see how does it look like. So it tells you clearly that chemistry, bio and geography is probably one group, and calculus, algebra and stat is probably another group. This is one part which I had not explained in R, so that's why I'm explaining it here. However, the focus of this particular video is explaining how to do factor analysis using SAS. So let's go into SAS. I have already got this data here, this dataset underscore efa.csv. Let me read this data here. So I have got all 300 variables, all 6 columns. All 6 columns are numeric. So this data is ready for factor analysis. I'm going to first do factor analysis. So proc factor data, here you put the name of the data set. I have demanded 2 plots, scree plot and loading, and I'm asking method CV min, which is like coefficient of variance minimum. So let's run this. So it is indicating you that it has read 300 variable and it has used all 300 variable. So first it is using principal component analysis for factoring, and it has found that there are 2 factors where eigenvalue is huge and then it goes down. That's what it is still shows in the scree plot as well as the variance explain. And that way, if you look at beyond 1, there are 2 factors which you like to retain, factor 1 and factor 2. And these are the loading of these factors, that the way it has come, and you can clearly see that it is little confusing here because it looks like all the variables are here. What this covariance minimum method has done, if you look at now, it looks like these variables has more loading on factor 1 and these are pretty small, and these factors have algebra, calculus and stats has huge loading on factor 2 and not on factor 1. Factor 1 it has, if you look at these variable, has quite small impact on factor 2. So factor 1 is primarily these 3 variables. These 3 variables has quite less loading, less regression coefficient. Factor 2 is primarily algebra, calculus, stats. These 3 variables has quite low impact. Now it is giving you that what is the variance explained by each of the factor, and it is giving you communality, means what percentage of total bio variance is explained by these 2 retained factor, what percent of geography is explained by these 2 factors. And it is giving you the graph that these 3 variables and these 3 variables are similar. Now what you need to understand, if you are thinking that this output is same as the output of R, actually it is not. Take a look. even the loading, if you look at here 0.9, 0.86, 0.9, if you look at, it was 0.86, 0.78, 0.87 and 0.17 here. What you are getting in case of SAS? 0.898690 and 0.11. So basically it is not same as what you are seeing here. Similarly, if you look at even the communality that was coming in case of bio at 74.8, means roughly 75%, here it is much more than that. Here it is 81%. Why it is happening? Actually, our SAS has many different things like than R, and it has so many different options. Like if you look at, if you put method, and now you have several methods of several process by which you can do this. You can select, for example, print, or you can select, for example, score or ML. Everything will produce a different output. Let me show it to you. Let's say if I select score, the output that you are seeing, take a look at the 0.90 and all those things. Let's see if it remains same or not. The point that I'm trying to say, okay, so this is not allowed, so that's different. Let's try ML method. Okay, and let's take a look. Are you getting the similar output or not? So if you look at, if you go below, let's go CV mean, which we were seeing earlier. If you look at it, it started producing semi-partial and it has changed a bit. One more thing, you try different rotation method like here, and you put equal to, you'll see SAS has so many options, and every options is going to produce different output. Take a look. If you look at here, this time it is showing eigenvalue 22, which you will not expect, because otherwise you expect eigenvalue to be at max 6. It is just different method by which it is taking, and some negatives are there. But go ahead and take a look at one thing. In each of the graph, if you look at, here 0.86, 0.87, 0.77, 0.87, 0.11. So if you look at, this is pretty close to what we were getting. Not really, because here it is 0.11 and what we had got is actually 0.17. Look at here, 0.80, 0.97, 0.49, these are close. The point that I'm trying to say, that there are so many methods and so many options available. With here you have many methods available, many rotational method available. But if you just go ahead and apply common sense, everywhere you'll find that script plot tells you that how many factors you should be taking. For example, everywhere it is saying that take 2 factors, and it is explaining you that which are the, like if you look at the graph, it is explaining you that which are the factors which appear similar. By looking at this graph, these 3 variables are similar, whereas these 3 variables again appears a group. In fact, these 2 are major group and these 3 are major group. This looks more closer to this than this. I will suggest that, if at all you start going too much into detail of this, this will become quite lengthy. But for the purpose of explaining how to do factor analysis using SAS and how to interpret the output, this is pretty sufficient. You need to look at eigenvalue loading, decide how many factors you want, and you need to look at this graph. These two are able to give you that how factors are loaded.